So welcome to all on the fourth day of this ATAL FDP on advances in solar photovoltaic and its design for electrical vehicle. So today once again we have with us uh, Mr. Dr. Abrar Ahmed with us. So he will be sharing basically some more content with us related to the electrical vehicle only, that how renewable energy can be used with the electrical vehicle. So I welcome Dr. Abrar Ahmed once
Thank you so
again.
much, sir. Thank
Uh,
you so much.
so Dr. Abrar Ahmed, uh, welcome, and I will request you to please start and share your knowledge with our participant.
Yes, sir, sure.
Abrar.
So before starting, I just want to confirm, am I clearly audible and my screen is visible?
Yes, you are audible and screen is also visible. Solar photovoltaic for electrical vehicle is your topic. Okay, so you
Yeah.
can proceed.
So very good evening to all the participants and respected sir. So for the today's lecture, my topic is the solar photovoltaic for the electrical vehicles. So as the name suggests, so I will be basically discussing about the different photovoltaic technologies, like types of for solar photovoltaic system, their significance, why we use the solar photovoltaic, and why we use the solar photovoltaic for charging the electrical vehicles, how we can achieve the zero emission by combining the solar photovoltaic and electrical vehicles. So, if I talk about the today's lecture agenda, so I will be covering the types of solar PV systems, benefits of solar power, components of the solar energy charging system for the electrical vehicles, and key benefits, and battery specification of different EV segments, charging methods and power ratings, electrical vehicle supply equipments, power ratings, battery swapping technology, and what are the Indian standards are made by the BIS, basically that is a Bureau of Indian Standards, and which comes or work under the IEC. Also, we will discuss the PV EV charging infrastructures and the solar application in the electrical vehicles. So let me first start with the introduction. So if we talk about the solar system, then the solar energy is a sustainable source of energy. It is an eco-friendly and non-vanishable renewable energy of source, which always remain, which is never going to end. So from the past few years, many government bodies, automotive manufacturers, and other stakeholders have come forward to explore the new schemes and new opportunities by combining the solar and electrical vehicle charging. And also, the cost of solar energy technologies have dropped continuously over the last 30 years. If we talk about the 20 years earlier, the cost of producing a single unit of power was very high. Now, as the technology is revolving and evolution is going in the in the solar industry, in the uh, if I talk about the solar module or in the inverter technology, the cost is drastically reduced for the per unit of generation of power. And if we talk about the installation convenience, then the PV modules may be installed on the rooftops to the building EV charging stations. Solar canopies installed on the parking lots make a excellent choice for the solar powered EV charging station. So basically, we can say the integrated solution, building integrated solution of PV. Nowadays, the flexible PV panels are also manufactured, or the solar cell enabled windows are also available in the market, which looks aesthetically also good. So it is a best option for the building integrated solution. And we all know that global trend indicates that both the EV as well as the solar industry have taken witness an exponential growth over the recent past years. And the challenges still exist way for the solar energy based on the electrical vehicle charging systems to become a mainstream option, because as of now the the electrical vehicles available in the market, now they have the battery capacity is more than 50 kilowatt, and it is not possible to attach or combine that much of power solar plant with the electrical vehicle. But we can integrate these like this much of power plant with the buildings as well as in the parking shed. So government and policymakers and auto manufacturer are exploring the feasibility of to address these situations. Also, if I talk about the business opportunities, then the PV and EV synergy is expected to open up the new window of business opportunities in the near future, and keep up the clean energy commitment. So let's understand the what basically I just initially start with the solar system, then we go to the integration of solar system with the electrical vehicles, and then I will discuss at the end the application of solar photovoltaics in the EV segment. So what does exporting to the grid means? Basically, if I talk about the this comes in the category of the grid connected PV system. So the power from the solar PV is generally used to supply your premises first. So first we utilize the power at our end. If excess power is generating, our power plant is generating excess power which is greater than the utilization of that power, then that is fed to the grid itself. So this is known as the exporting of the grid. Now let us look at the different types of PV systems are available now, based on their configuration. So basically there are three types of solar photovoltaic system. One you can see on the screen that this one is the grid connected system without a battery backup. It does not have any battery backup. So these solar PV system are connected to the electricity grid and are the most common. And during a day the solar power is generally used first by your premises and before using electricity from the grid. And if you don't use all your solar power each day, then the excess may be exported to the electricity grid. And the government which have the facility to connect and export the energy to the grid or utility grid, then the government will pay some amount incentive amount for the per unit amount. Like in our Rajasthan we have earlier we were having the 1 rupee 75 paisa per unit. Maybe government have, I don't exactly have the figures right now, but I heard that the government has revised that tariff, and I think it is made to the 3 rupees per unit to export the energy to the grid. So it basically consists of a solar module which generate the DC power, and inverter is used to convert this DC power into the AC power to make the power compatible with the grid. And the net meter solution is provided there. So that net meter basically measure the import and export units, and according to that utility generate the bill for you and send the bill to the consumers. Next one is the grid connected with the battery storage. It has its own advantage. Suppose in daytime the excess power is generated and we are not utilizing it, and that period of time we can store this energy into the battery bank, and we can utilize the this saved or stored power in the night time. So it eventually save more money and your bill get low, and you still have to backup support of electricity from the grid. So they are also known as a hybrid solar power systems. Next one is the standalone system, or you can say the off-grid solar. So these solar PV system cannot connect to the grid and therefore must have their own battery storage or a backup generator like diesel generator or power supply. And the cost to buy and install a standalone system with the backup generation battery storage are much higher than the grid connected system. because it when you are they are only installed in the remote location where the cost to connect to the electricity kit is much higher. Suppose you are in the remote location where the grid supply is not present, and the pole from your premises is the distance from the your house is very long, then it is the cost become very high to get connected to the grid. In that situation, we can go for the off grid type solar systems. Talking about the benefits of using the solar power, we all know that it has the zero emission. So solar electricity is one way to power your home or business that benefit the environment. There is no direct greenhouse gas emission because the electricity is made from the sunlight rather than burning the fossil fuels. And we all know that the coal and gas are the fossil fuels and will eventually run out. And as our state is a sunny state, so there is a plenty of sunshine all year around. So it will basically save your bills. You should see a saving on your electricity bill because you will using the power from your solar panels during the day rather than just from electricity grid. And also, if you are about to sell your property, then it will add the value to your property. So the buyer will get the extra benefit of the solar as a system installed. Maintenance cost is also low. The grid connected solar PV system are generally very low maintenance with the occasional cleaning and regular health check by a licensed electrical contractor. Then the solar panel should last around 25 years. Also, most of the manufacturers are providing the warranty of the solar panels is more than 20 years. So it is just likely that inverter will need to be replaced at least once in this 20 years of span. Or batteries, if you have the battery integrated, then the battery storage system, then in every like 5 year or 7 years you have to replace these batteries also. Also, some benefits like government schemes also there, which providing the subsidies for the per kilowatt installation. So government is also promoting to install the solar power plant at your home or businesses. So now the question arises, are electrical vehicle purely green mode of transportation? So EV are not a solution to pollution. It is just transforming the problem from fuel to chimneys. And the solution to pollution lies in the solar power or renewable energy. If we do not integrate the renewable energy source or solar power to the electrical vehicles, then we are just transferring the problem from fuel to the chimneys. Because for generation of the electricity, eventually you have to burn the coals. You because most of the electricity generation in our country is came from the coal power plants. So it is very important that we just cannot eliminate the problem by just adopting the EVs. We need to integrate the EVs with the solar power like renewable energy source. So the integration of renewable energy will make the EV truly cleaner than the conventional fuel vehicle. And the vehicle taking into account the lifetime CO2 emission. Eventually, lifetime, if we compare the lifetime CO2 emission, it will drastically reduce. So the distributed solar energy will help reduce transmission and distribution losses because we are not if we talk about the, let's suppose we do not integrating the solar system to the EVs, then the from the generating station to our consumer end, there are lots of power losses are there that can be minimized by this uh, distributed plant we installed at our home or offices or in our parking sheds, so thereby reducing the lifetime CO2 emission as well as the operating cost of the EVs further and accelerate their commercial feasibility. Then only we can commercially adopt the EVs. So let's discuss the main components of the solar energy charging system for we install the electrical. As you can see in the picture that in a parking lot, uh, panel module is there, which is basically a maximum power tracking base solar panel arrangement. And if we talk about the main component of this system, that is the solar PV panels. So as the if we require the to charge the electrical vehicles, so certain level of voltage is required. So in fast EV charging station, large array of electrically connected solar panel would be installed to generate the required amount of power to charge the electrical car. And the crucial factor here is the angle of the solar panel, because it is only going to decide the output efficiency of these panels. It is very important to track the sun so that the solar panel can produce the maximum power. And the other factor being the latitude, longitude, and the weather condition, that where you are installing that solar panel, what are the environmental condition there, what are the day temperature is there. So these are factor also if basically affect the power generation or efficiency of the solar panels. And the solar panels are attached to a movable motor controlled solar tracker based on the input from the basically a microcontroller, which is a brain, which basically takes the some sensor inputs and basically rotates these motors to basically track the and move the solar panel axis to receive the maximum sunlight at any given day in a time. And the second part is a microcontroller may be from the any manufacturer like Texas Instrument, NXP, Renesas, or you have Microchip or microelectronics. So the main responsibility of these controller is to basically ensuring the maximum power efficiency of the solar generation through the MPPT controller, and storing the extra energy generated from the solar PV panels into the storage battery cells. So these all things are taken care by the microcontroller. The firmware is designed to do so. So they perform their actions according to the inputs. And third one is the motor to control the solar panel axis rotation. So the bidirectional motor is used to control the solar tracker, basically based on the sensor's input or using the solar position algorithm. The solar position algorithm calculate the sun position based on the elevation values and based on the time, date, location of the earth, and this all information are processed, and then the command is given to these motors to rotate in the particular direction to get the maximum solar radiation. And third one is the DC-DC converter with the MPPT. Why we require that? Because in the complete daytime, the solar irradiance change variably. So the generated DC power is also in variable nature. So an electric DC-DC converter help in converting the high power generated from the solar panel to the required EV battery voltage. So we make these generated voltage incompatible with the EV battery voltage, and the DC-DC converter use the maximum power point tracking to support the PV panels to operate at the maximum power. And this can be a software implementation or maybe a hardware implementation through the SoC, system on chip, which is already like suppose in current scenario, if we want to like make a inverter, then already Texas Instrument already providing the predefined SoCs or ICs, which is dedicatedly to just produce the inverter. Like in our organization, we are in the metering field. So Renesas has developed a chip which is basically RL78 series, and which is basically dedicated IC for the metering field itself. So predefined functions are already there in that chip. So these type of chips are already available in the current market also. Next, we talk about the communication. So the battery monitoring system, basically we known as a BMS of a electrical vehicle, should communicate with the solar power charging system to ensure that the optimal charging without any fail. And the charging device communicate with the BMS so that the electrical vehicle get charged at the rated current or at the optimal current. So next one is the interface. So when we go at any charging station, we have provided with the human machine interface, basically HMI, to display the various parameters including the solar energy capture, the energy consumed by the EV battery while being charging, how much percentage charging remaining, how much power the EV has consumed while charging the to the, let's suppose, to up to 80% or 100%. So these interface are also the part of that charging infrastructure. Next one is the EV battery charging equipment. So the Society of Automotive Engineering, known as SAE, specifies basically three level of charging standards. So level 1 charging, level 2 charging, and level 3 charging. Level 1 charging is the lowest one. A level 1 charging equipment uses standard household power outlet, which is available in our home, like at the 230 volt 50 hertz supply. And the fully charging an EV using L1 or level 1 charger, it will take overnight time for a four wheeler. If I talk about any cars, for the two wheelers, it will maybe around 5 to 6 hours, maybe 3 hours. It depends on the battery capacity of that vehicle. So in L1 charger, the 8 to 12 hours or even more, depending upon the EV battery type. A level 1 charging is best done at home overnight when the vehicle uses in the least. In level 2 charging, in level 2 charging described, it is work on the 240 volt AC charging and commonly used for the daily commute. Like level 1 2 charger can fully charge an EV in around 4 to 6 hours. And if I talk about the level 3 charging, this is the DC type fast charging. So level 3 charging has the highest rate of pushing the power in the battery bank. So the level 3 charging equipment charges a EV through a high voltage DC, approximately 480, 500 up to 600 volt DC, and support charging up to the 500 volt. So in fast charging mode, L3 charger can supply EV with 80% of charge in just like within an hour only. Or maybe some manufacturer providing the like this capacity of up to only 30 minutes. So let's discuss some key benefits of using the solar PV panel as an energy source for EV. So about 80% of the solar panel module can recycle using the advanced of life uh, end of life recycling technique. It is basically a technique to basically recycle the after the lifespan of a module. We need to recycle it. If we do not recycle it, then the electronic waste will increase, and it will eventually, we are focusing for the sustainable environment, and again by generating this electronical waste, we are polluting the environment. So we need to recycle it. So the end of life recycling technique is used, and many companies are also there, they are doing such a great job, and the end product of this recycle can be used for more productive processes. So the International Renewable Energy Agency, which is basically known as a IRENA, has observed that various material recovered from the solar panel recycling could be $450 million by the end of the 2030. And if we talk about the lifespan, then the average lifespan of a solar panel manufactured today is more than 20 years. And if I compare with the life of this battery and inverter, then that need a replacement in every 5 to 20 years of installation. And next we talk about the improvement in technology. This enables the solar energy to chart new record in terms of power generation and capacity. So our government has also the target of by the 2030, whatever the total installed renewable energy capacity we will going to have, among which we are going to focusing on 40% we should generate from this solar photovoltaic. So our India and our government is also have the like vision of achieving such a high mark. So solar energy, one of the cleanest option we have for fueling the electrical cars. So otherwise, whatever type of electrical car you are using, if it is a fully battery enabled BEV or HEV or PHEV or fuel cell based, then all we are going to charge from that plug we available at our home, and that power is emitting. To generate that power, the carbon footprint is there, some carbon footprint is there, but if we integrate this type of renewable energy source like solar, then the carbon footprint will become zero. So the solar panel installed at home can help significantly in saving the electricity cost through a controlled charging schedule. And if we talk about the prices, then the price of the solar installation have reduced considerably over time in an encouraging more people to invest in most of the earlier we can see in our around also, our surrounding also, that earlier we were not having a single solar plant, few of people having that solar plant, but at the government focuses on the renewable energy system, providing incentives, providing subsidies. Now as the solar technology also grown, so the cost of the overall installation cost and the capital cost is eventually decreases, and this is basically encouraging more people to invest in it. So this is the most popular form of renewable energy. If we talk about the limitations of solar installation on the EV, suppose we directly want to integrate the solar photovoltaic panels with the vehicles or electrical vehicles, then it is not a feasible one, because if we talk about normally talk about 1 kilowatt of rooftop system, so how much space it is going to take? It takes around approximately 12 square meters, which comes, if we understand in the square feet, then it is around 130 square feet. So we do not have that much of space on our vehicles, and it is only for the 1 kilowatt. Let's suppose your vehicle have the battery capacity of let's suppose 50 kilowatt, and your system is let's suppose you have installed 1 kilowatt, then your system will take much longer time to completely charge that battery. So the idea of putting photovoltaic cells on the large latest generations of electrical vehicle was initially ruled out, and the power generated by the solar cells would not be enough to power the car alone, because it is not a feasible one to install the solar panels on the EVs. So but little we can help, as they say, and the power generated by photovoltaic cells we can use in some store in the battery pack, and the power to power the interior lightings, alarms, clock. We can charge the auxiliary power supply, that we can do that. So or keep the help the cool the car or recharge its batteries. And the because we have the limitation on the electrical vehicles, because the roof and bonnet is the only option to install that solar panels, so particularly on the day when the sun is blazing down, so the photovoltaic cell gather energy at no cost, which could be sent directly to the battery if the car is electric, thus boosting its free electricity. So if I talk about the battery specification of different EV segment, then if we talk about the two wheelers, you can see the battery capacity is around 1.2 kilowatt to 3.3 kilowatt, and the battery voltage range is around 48 to 72 volt. But as of the market scenario is going on, now we have the two-wheelers up to 6 kilo, having the battery capacity of up to 6 kilowatt. Then we have the second segment, which is a passenger or goods three-wheeler e-rickshaw, or you can say you can see that the battery capacity of these segment is 3.6 to 8 kilowatt, and the battery voltage is 48 to 60 volt. And if we talk about, we have the car category segment, we have the two generation. In generation 1, which we were having only up to 21 kilowatt of battery capacity, and now the latest one, we have up to 80 kilowatt of battery capacity, and work on the work in the fast charging mode, which battery voltage operating voltage is around 350 to 500 volt. As you can see on the screen, the charging method and power rating graph. In the left half of this slide, you can see the segment of AC charging, and in the right half of this slide, you can see the DC charging. Okay, so the EV charging involve supply of a direct current to the battery pack. Either we can directly supply the DC power to the battery bank, or we can provide an AC power. Then the onboard charger on the EV will convert that AC power into DC and then fed to the uh, battery bank. So the conductive charging can be AC or DC. In case of AC electrical vehicle supply equipment, the AC power is delivered to the onboard charger and while converted to the DC. And the DC EVSE convert the power externally and supply DC power directly to the battery and bypassing the onboard charger. So if we look at the classification, then the AC and DC charging are further classified into four charging mode. Mode 1 to 3 are comes under the AC charging, and mode 4 pertaining to the DC charging. If you look at the diagram, the mode 1 and 2 are applicable for connecting an EV to the standard socket outlet, which is available at our home, utilizing a cable and a plug. So mode 1 is also known as a dumb charging and permit no communication between the EV and EVSE, and is used it not recommended. So the portable cable used in mode 2 has an inbuilt protection. So the the charging method we are currently using with the two wheelers, we have the mode 2 type, second type of charging, which have inbuilt protection and control capability, and is typically used for the home charging. Mode 3 and mode 4 provide the separate charger. So the separate charger is installed from the third party or maybe from the manufacturer of your EV. So the separate charger device to supply the power to the EV and have improved control system that uses the commercial or parking charging. So as you can see in the picture that it is a charging station which is installed by the Tata in a society where you can charge the two-wheeler as well as a four-wheeler. So the you can see in the table the electrical vehicle supply equipment power ratings. So the normal charging rating is up to 22 kilowatt, and high power charging going up to 200 kilowatt. So with the power rating of approximately 500 kilowatt globally available, so they are largely applicable for the heavy vehicle like buses and trucks. So these are the ratings of the electrical vehicle supply equipment, EVSE. Now the one very interesting concept is also coming, and BIS is also working on it to make a standard for it for the Indian market scenario, so that interportability will be there, so that all should follow that same standard. Like few days ago, if one of you have read about that, BIS has mandated the use of Type C charger for every wearables and mobile devices. Earlier Apple was having their own charging like standard or plug there. Now they have to compliance with the BIS standards if they want to sell their mobile phones in the Indian market. So BIS also working on to making a standard for the battery swapping. So, a alternative battery charging method is the receiving global attention. It is a battery swapping, which is a depleted EV battery is removed from the vehicle and replaced with the fully charged one. Now you do not need to like worry about the range issue, or like you need to like have to wait for, even you are using the fast charging, then you have to wait for around 30 minutes or 1 hours. In this type of technology, you just go to the battery swapping station, you just grab a charge one battery, and just you just portable, which is a removable battery, you just remove from your vehicle, and just put the another freshly charged battery in your vehicle, and you are good to go. So this is a very new concept, which is also like government is also focusing on this this type of technology. So the battery swapping station is standalone device in which the battery are placed and removed manually from the individual slots. Usually, you can see in the picture that in the like panels type devices, there number of battery modules are there which are getting charged, and one person from his three wheeler is swapping the battery from behind of the vehicle. So this is the concept of battery swapping. Next, what are the standards available for the electric vehicles in India as well as globally? So the standards ensure interportability and compatibility of any electrical vehicle supply equipment with all EVs, because if we have, let's suppose, 65 number of OEM manufacturer, or we have 255 models of EV models are available in the market, and each one of them making their own like plug or own battery level standard, then it is not going to help in the sustainable environment. It is become very difficult for the customer to switch between a different type of charger, or whether do not want to avail a facility from the particular manufacturer. So it become difficult. So the Bureau of Indian Standard, BIS, and the National Standard Body of India is responsible for formulating the EV charging standard for the country. So BIS is basically, earlier I have already told you that the it is a member of the International Electrotechnical Commission, basically IEC, we known as in short form, which is a global body that is developing a reference standard to ensure the interoperability and minimize the uh, trade, and also uh, minimize the trade barrier for the electrical vehicle and their components. And so if we talk about which Indian standards are defined for the electrical vehicle, then IS 17017 is the key EV charging standard, which have several number of parts there. So it is basically comprising the three parts and six sections. So in IS 17017 Part 1, it provides the basic feature of all EV charging systems, and AC EVSE must adhere to these standards, and the specific AC connector standards in the IS, what type of connector is going to have the EVSE, then that is defined in the IS 17017 Part 2. For both AC and DC EVSE needs a conform to technical standard of IS 10017 Part 21 and 22. So addition to the Indian standard for AC EVSE have been approved for light EV and e-cars for use in the parking areas. So the picture you are seeing the connector, which is you going to basically find in the parking EV charging infrastructure, which is installed in any uh, parking of like a parking lot, or in any if you go in the mall, if there is a charging station, charging infrastructure is there, this type of plug you are going to find there. or the AC, and this is for the Indian standard for the DC charging. So IS 1017 part 23 describe the requirement of a DC charging station, because DC is a fast charging, and the power handling capability of that particular plug or cables, everything should be high. So it is defined in the IS 17017 part 23. And recently the BIS has finalized the IS 17017 part 25, which is especially for providing low DC power for less than 7. Let's suppose for two wheeler also the fast charging concept is coming. So the for the that type of charging infrastructure, the IS 10717 defined part 25 for the EVs which have the battery capacity less than 7 kilowatt. And due to the requirement of the digital communication, because as we defined in previous slide, that components of that charging infrastructure, so communication should be there. So the due to that requirement, the digital communication between the DC, EVSE and EV, so the data communication standard is defined in the IS 17017 part 24. And when we talk about the combined charging system like AC as well as DC, then that communication will be as a IS defined in the completely new BIS, IS standard, which is a IS 15118 series. Now let's talk about the PV EV charging. So there are basically two possible approach to charge a EV using a PV, and mainly the PV grid or a PV standalone. Either we have the grid connected PV system, or we have the standalone system which is having the storage capability. So the PV grid charging has the advantage because during insufficient solar irradiance, the charging can be carried out using the grid. It is more flexible because in the absence of the EV, the PV power can be injected to the grid. On the other hand, the PV standalone is more beneficial because in remote areas where utility supply is not available or too costly, then we can store the energy. Let's suppose you have installed an standalone system, then you have installed the 5 kilowatt and your daily running peak load is around only 3 kilowatt, then you are generating the extra 2 kilowatt that you can store in the batteries during the daytime, and you can utilize that power in the night time. So the electrical vehicle charging imposes an additional load basically, because let's suppose from RSAB we have taken the load session of about only 5 kilowatt. Now you have purchased the electrical vehicle. Let's suppose a four wheeler you have purchased. Now the charging capacity, let's suppose the load capacity is around 10 kilowatt. Then this is the additional burden on the system. So the electrical vehicle charging impose an additional loading to the electric kit because the current drawn from the grid and particularly for the fast charging can be very large. And further, if the charging take place during the peak hour, let's suppose uh, we don't have that variable like availability based tariff here. So but other country have that for every hour or every minute they basically price get changed, price get changed according to the market requirement. So if during the peak hours you have to pay the high premium for the tariff, so offset this burden, the PV grid charging system is proposed. So this will eventually like help you to reduce that bill. And availability of PV power reduces the spinning reserve capacity and improves the grid stability because it is a distribution environment. You do not have any power loss there. So eventually you are supporting the grid by providing the healthy power to the grid. So besides that, the during the absence of vehicle, the electricity from the PV can be exported to grid for the momentary gains. So this is the like you can see the block diagram of a solar PV system integrated to charge the electrical vehicles. You can see in the block diagram we have the PV solar panels, which basically generate the DC power, and DC-DC converter convert this DC power into DC power with the MPPT to basically make the compatible or make the constant voltage at the optimal power. So grid is also there, using the inverter which have the bidirectional capability. A central controller is there which basically control the flow of all powers, whether you need to take the power from the grid, whether you have to take the power from the solar PV system, you have to charge the battery or take the power from the battery. So we have at different level we have the different type of bi-directional controller there, and the EV have the BMS which basically communicate with the energy storage unit to basically ensure that your vehicle get charged in the healthy manner. And also a new technology is also coming in this Auto Expo of 2023. The Hyundai has launched the Ioniq 5 model, which have the V2L capability, vehicle to load. Basically, you can drive approximately 300 to 500 watt of load from your vehicle itself. And also in coming future, we have the V2G facility, vehicle to grid capability, which will uh, basically facilitate the support the your grid from your EV itself. So this is all about the standalone. This is the PV grid charging station. If we talk about the standalone charging, which is integrated for the EV, then you can see we have the different configuration. So power, maybe that system can have a direct controller to charge the EV, but I may not suggest, because the generated power, if it is not enough, you cannot charge your EV at a fast rate. So if you have the charge controller and the energy storage unit, then it is more like efficient compared to the previous one. And if you have the bi-directional converters are there, then it is more like with battery system it is become more efficient. So the application we are talking about, that solar directly integrated to vehicle, some of the experiment has been done by several researchers as well as different laboratories also in different countries. So the solar vehicles are those vehicle which is completely powered or charged by the solar energy. So the usually photovoltaic cells containing a solar panels convert the sun's energy directly into electrical energy. The term solar vehicle usually implies that the solar energy is used to power all the parts of the vehicle. We have not going to plug any external plug to charge the batteries or anything. The vehicle is completely solar. So let's see some of the example. If we talk about the solar car, the first solar family car was the Stella, which was built in 2013 by the students in the Netherlands. And this vehicle have the capability of 890 kilometer of one charge during sunlight, and it weight was around 390 kg, and it has the 1.5 kilowatt hour solar array. So the next version, the Stella Lux, which is a evolution of the Stella earlier version, which is showcased in 2013. Again, Stella Lux was produced in 2015, which have again marked the record of 1500 kilometer in a single charge, and during this Stella Lux is capable of 1100 kilometer during the daylight. Next, the solar buses. Solar buses, you can say that the solar charge bus is a bus that powered exclusively or mainly by the solar energy. So the solar solar panels are installed on the roof of the vehicle bus, and normally implies that the solar energy is used not only for powering the electrical equipment on the bus but also for the propulsion of the vehicle. So this is the example you can see in the picture, solar powered minibus in which is made in Berlin, Germany. Then we have in 2010 the planet solar, which is approximately 30-meter long and 15.2-meter wide catamaran yacht powered by the 470 square meter of solar panels, which is unveiled in 2010. So it is so far the largest solar power boat ever built. In 2012, Planet Solar became the first ever solar electric vehicle to circumnavigate the globe. And the low power density of current solar panel limit the use of solar propelled vessel. However, boat that uses sails and rely on the battery power for electrical appliances. So here solar panels have become the popular for recharging batteries as they do not create noise and require fuel and often can be seamlessly added to the existing uh, deck space. Next is the electric aircraft. It is not dedicatedly that any man is sitting inside it, like one or two flights were there. You can see in the Gossamer Penguin and a Swiss solar powered aircraft, Solar Impulse, completed the circumnavigate of world in 2016. So the solar ship basically refers to the solar power airships or hybrid ships, or it is mainly application in the unmanaged aerial vehicles, which is a main application in defense systems or in defense armies. And the last one is the solar powered spacecraft, which is basically you can see in satellites also. We have the solar space station. In solar space station, we have like these type of solar panels installed on that. But these solar panels are not responsible for the vehicle to move in the space, but it is mainly for the powering up the day to day like activities like communication satellite containing the multiple radio transmitters which operate continuously during its life. So solar cell basically used for that part of type uh, to just basically charge the energy storage system or directly giving power to the system. So solar power is not generally used in adjust the satellite position. However, the useful life for the communication satellite and will be limited by onboard station keeping fuel. So this is all about from my side for the solar photovoltaic for the EVs and the applications or solar photovoltaic in the different area of electrical vehicles. So thank you so much for keeping the patience. I am open for any question you can ask me.
Yes, anybody has any question, then he can ask Dr. Abrar. Okay. Uh, so, Dr. Abrar, you have pointed a very good thing at the beginning that though people are hoping that we should have an solar panel over the electrical vehicle, but the size is not permitting us, in the sense that the area on the rooftop of the either three-wheeler or a car is so small that you cannot charge the car or three-wheeler within few hours. In fact, if you want to install, for example, we did an experiment in
Yes,
our
sir.
department. Okay, so we have installed an even 465 watt of solar panel,
Yes, sir.
but that 465 watt of panel on the rooftop of the that three-wheeler auto rickshaw, okay, that is also taking near about 12 hours to charge it.
Yes,
So
sir. Yes, sir.
before starting it, it has to be kept for 1 day. Okay, if so your battery is at the level of the deep discharge and you want that your battery to be fully charged, then it will again take 1 day to completely charge it. and then you can move forward on the next day to have any type of transport service.
Yeah, for the propulsion of vehicle, like it is not feasible. But for other facilities, like suppose we want to maintain the cooling, or we want to provide the interior lighting in the our vehicles, we can basically used as to charge the auxiliary storage systems.
Yeah,
Not
definitely
just
for auxiliary purpose, electrical purpose, like lighting, we can go for the solar, but not for the complete. We depend
because
upon the
eventually the only constant is the area required to install these solar panels. This is the
yeah,
main concern if we integrate in the like electrical vehicles.
yeah. But it can be an we can say secondary source.
Yeah, yeah,
Okay,
yes.
it can act as a secondary source for the complete EV system.
Yes.
Okay. So anybody has any question in the chat box or you want to speak?
I hope I have cleared some of the
Yeah.
things
Uh,
regarding the
so
charging stations and charging infrastructure. What are the different types of chargings are available in the market, or what the India has the standards for our EVs.
yeah. So thank you, Dr. Abrar. Thank
Thank
you
you
very
so
much
much, sir. Thank you so
that
much.
you have spared once again golden valuable time with us and with my participants. And in the beginning only, I have invited you that you just come to Udaipur and please throw light on some practical session
Yes, I
related to
am.
e-vehicles and other solar photovoltaic system. But you said that you are busy, therefore it is very difficult for you.
If it was possible, sir, I would definitely have come there.
Okay, okay, no, no problem. I will not force you, but through online system also you have devoted your time and enrich our participant with your knowledge, and definitely I hope that my participants are being benefited by this.
Yes, sir.
Okay,
They have
so
very patience, and the most interesting thing, or you can say good thing, that they do not have any questions after getting
Yeah,
too much of.
maybe due to the hesitation or maybe due to the because a newer topic is there, therefore
Yeah,
people
yeah.
may not be asking the question. One news I want to give to my participant that yesterday only uh, drastic event has happened in Udaipur only where and showroom was a showroom of
Yeah,
electrical vehicle.
I also heard that news, sir.
Yes.
That
Uh,
electrical vehicle showroom get like fired.
fired and in fact 40 more than 40 vehicles have burnt. Okay, and the probable reason was that uh, that they were being kept left uh, for charging process throughout the night. So one of the vehicle get overcharged and thereby the battery burst.
So
Okay.
basically, one thing, as the most of are the like PhD scholars and doctors already. So I'm enlightening some of the like area of research in the field of electrical vehicles. So electrical vehicles have very open field in the developing a fast charging infrastructure, battery management system. As because we are moving in the fast charging system, so lithium ion battery are there, so the cooling is very important factor for the lithium ion battery system. So the research area is open in the field of charging technology, of, producing new algorithms for managing the battery's health, monitoring the battery health, increasing the lifespan of the battery technology, like motor technology to produce the efficient or more power torque by utilizing the less power from the existing solutions. And also in the in the field of power converters, there are lots of opportunities in this current EV infrastructure market, as well as adopting or promoting the EV to adopt. Sir, you are muted, sir. Kindly unmute yourself, sir.
So very correct. You have really throw light on some research topics also. So thank you very much, Dr. Abrar. And
Thank you so much. And
there is a 10 minutes break is there. Okay, we will again meet at 8:30. Okay, with a new lecture that the batteries for the e-vehicles. Okay, this is a very important topic. Okay, so it will give you a knowledge about what types of batteries are there meant for the electrical vehicle system. Thank you, Dr. Abrar, and thank you to
Thank you,
all
sir. Thank you so
participants.
much for,
Please remain
thank you
intact.
again for
This
inviting me.
10 minutes break is there. Thank you.
Thank you so much, sir. Thank you, guys.